We're going to continue rationalizing the denominator, just looking at slightly different situations. The issue that we have is we have a square root in the denominator, and that's not considered simplified. So, in this case, even though it looks a bit more complicated, we just need to multiply by the square root of 6 over the square root of 6. We're just going to multiply by a form of 1. And that's going to give us negative 8 root 6 over 3 times 6. And we know that 3 times 6 is 18, so we have negative 8 root 6 over 18. And now we just need to look and see, does the fraction negative 8 over 18 reduce at all? And it does. So we're going to keep going a little bit further with this. Negative 8 over 18, both are divisible by 2, so this will be negative 4 root 6 over 9. Now we've simplified and rationalized this thing. The square root of 6 doesn't go further, 4 over 9 doesn't go further, so we're done. Why don't you try another one like that? I'll have you try 2 of them actually. 5 over 2 root 5. And then when you're done with that, try negative 9 over 4 root 3. Hit pause and give it a shot. Let's see how you did. For the first one, we need to multiply by root 5 over root 5. And this would give us 5 root 5 over 2 times 5. But 2 times 5 is 10, so this is 5 root 5 over 10. And 5/10 simplifies to 1/2, so this would be 1 square root of 5 over 2. Looking at the second one, we've got that square root of 3 in the denominator, so that's what we need to do to rationalize that. This will give us negative 9 root 3 over 4 times 3, because the square root of 3 times itself is just 3. But 4 times 3 is 12. And negative 9/12, that'll reduce to negative 3/4. So negative 3 root 3 over 4. Let's look at a different situation. Still the same idea, we need to rationalize the denominator. Just starts differently. Here we have the square root of 5/12. It'd be nice if that fraction reduces, but it doesn't. And one of our rules is we can't have a fraction in a square root. It's not considered simplified. So, one way to approach it is to make this the square root of 5 over the square root of 12. And some of you may want to simplify the square root of 12 right now, and that's okay. You could do that. I'm going to multiply numerator and denominator by the square root of 12 over 12. I'm going to choose to do it that way, and that's going to give me the square root of 60, which probably simplifies, over 12. The square root of 60, well, let's see, that's 6 times 10, but that's not helpful. It's also 4 and 15. And the square root of 4 is 2, so this is 2 root 15 over 12. But 2/12 reduces to 6, so we have root 15 over 6. Now someone's probably wondering, well, what if I wanted to simplify earlier? Well, I'll do that in a slightly different color just to answer that question. So someone that wanted to simplify the square root of 12, they would have broken it up into 4 times 3. And that would have been square root of 5 over 2 root 3. And their issue is they've got to get rid of that square root of 3 in the denominator. So when you rationalize, you'll get the square root of 15 over 2 times 3, which is the exact same thing as we got up here, the square root of 15 over 6. So either way you approach it, you're going to get the same thing. Let's try one more like that. The square root of 10 over 50. Now this one's a little bit different just for one reason. You could simplify that fraction to begin with. You don't have to, but you could. Notice you would get the square root of 1/5. Doesn't go further, but we can't have a square root in a radical. This would be the square root of 1 over the square root of 5. And if you multiply numerator and denominator by the square root of 5, you would get the square root of 5 over 5. And now it passes all of our rules. So that's rationalizing a denominator where you're dealing with just a single value.